doing local linear approximation today. And the first thing I have to do is explain what that even is. So coming over to this graph, this is the f of x equals sine x graph. Basically what the local linear approximation theory is saying is at any point x that you can take the derivative of its corresponding y value, so it makes a point. At that point, if you can take the derivative at x, it eventually, if you zoom in, it's going to look like a straight line. So for example, if we took the x value of pi, and so it would be pi and 0 for this point, you can take the derivative of sine x at pi. So when you zoom in a super infinitesimal amount, this looks like a straight line. So in order to find this point, we just have to use the equation of a line, which is over here. So we're going to go ahead and do y minus y1 equals m times x minus x of 1. So up here, we're looking for the local linear approximation of f of x equals sine x at x equals 0, and then we're going to use it to approximate sine of 2 degrees. So what we have here is plug in 0 for sine of 0, or for sine of x, let's get sine of 0, which is 0. Then we're going to take the derivative of sine, and we get cosine, and plug in 0 at that point to get the slope, and that equals 1. So now we're going to plug it in to the equation of a line to get y minus 0 equals 1 times x minus 0, which simplifies to y equals x. So that is the equation of this line over here, because at 0. So the equation of this line, which is going to be like there, is y equals x at that point. So now that the sine of 2 degrees is relatively close, we can use that to approximate other values. But the farther you get away from that one x value point, the less accurate your approximation is. So what we're going to do now is we are looking for sine of 2 degrees. Well, the first problem is it's in 2 degrees and we need it in radians. So we're going to come over here and use our conversion factor, multiply it by pi over 180, and we get radian, our radian value is pi over 90. So that is the x value that we have to plug in and figure out the approximation for. So now all we have to do is plug it into the equation of our line, which luckily for us simplifies to y equals x. So y equals pi over 90. That's basically it. That's our answer right there. And it's this number. Okay, so that's our approximation of sine of 2 degrees, or sine of pi over 90, based off using the local linear approximation. Now if you actually plugged in sine of pi over 90, you would get this number. And these two are ridiculously close. They're off by just a few thousandths. So as you can see, the closer you are to the x value point, the more accurate your approximation is going to be. The farther you get, the less it'll be. And that's why this whole thing is called local linear approximation, because the closer you are to that point, the more linear it's going to be. And that function is said to be, or have the local linearity, I'm not even going to say that right, at that point of x. That's